of the following statements are true regarding the molecule given below? First, we will draw the Lewis structure for this molecule. CH3, then carbon-carbon triple bond, CHO. These carbon atoms are labeled as A, B, C, and D. There are 4 center atoms in this molecule, and we will find the number of Vesper units around each center atom. Using the Vesper units, we can find the hybridization and the electron pair geometry of these center atoms. Then we can draw the geometry of this molecule. I will start with CB and CC. There's a single covalent bond and a triple covalent bond around CB. Therefore, there are 2 Vesper units around CB. There's a triple covalent bond and a single covalent bond around CC. Therefore, there are 2 Vesper units around CC. If there are 2 Vesper units around a center atom, the hybridization is sp and the electron pair geometry is linear. Now we will draw the geometry around CB and CC. There are 2 Vesper units around CB. Therefore, hybridization is sp, the electron pair geometry is linear, and the bond angle is 180. Next, I will move to CD. There are 2 single covalent bonds and a double covalent bond around CD. Therefore, there are 3 Vesper units around CD. If there are 3 Vesper units around CD, the hybridization is sp2 and the electron pair geometry is trigonal planar. Now we will draw the geometry around CD. There are 3 Vesper units around CD. Therefore, hybridization is sp2, the electron pair geometry is trigonal planar, and these bond angles are approximately 120. Finally, we will check the number of Vesper units around Ca. 4 single covalent bonds around Ca. Therefore, there are 4 Vesper units around Ca. If there are 4 Vesper units around a center atom, hybridization is sp3 and the electron pair geometry is tetrahedral. Now we will draw the geometry around Ca. There are 4 Vesper units around Ca. Therefore, hybridization is sp3, electron pair geometry is tetrahedral, and these bond angles are approximately 109.5. This question asks you to find the true statements regarding the given molecule. Statement A. All 4 carbon atoms lie in the same plane. If you want to get an answer for these type of questions, it's easy for you to focus on sp hybridized or sp2 hybridized center atoms. I will start with CD. The hybridization of CD is sp2 and these 3 electron pairs are arranged in trigonal planar geometry and the bond angles are approximately 120 degrees. Therefore, these 4 atoms lie in the same plane. Now we will focus on CB and CC. The hybridization of both carbon atoms are sp. The electron pair geometry is linear. The bond angle around each carbon atom is 180. Therefore, these 2 carbon atoms CB, CC and the 2 atoms connected to these 2 atoms are in a straight line as well as they are in the same plane. Therefore, CA, CB, CC, CD and these oxygen and hydrogen atoms, they lie in the same plane. Hybridization of Ca is sp3. Therefore, the electron pair geometry around Ca is tetrahedral and it has a 3D geometry. Therefore, these atoms are not in the same plane. Statement A, all four carbon atoms lie in the same plane. Now you can see not only these four carbon atoms, oxygen and hydrogen are also in the same plane. These six atoms lie in the same plane. Therefore, statement A is correct. This is an additional information. Around CB and CC, the bond angle is 180 degrees. Therefore, these four carbon atoms are in the same plane as well as they are in a straight line. Statement B, the angle between CDH and the CDCC bond is approximately 120. So this is the CDH bond. This is the CDCC bond. The question asks you about this bond angle. Usually, the bond angle is 120 if these three bonds are identical. These three bonds are not identical, therefore, these bond angles are approximately 120. Therefore, the second statement is also correct. The third statement, statement C, between CB and CC, there are two sigma bonds and one pi bond. This is the CB-CC bond. There's a triple covalent bond present between CB and CC. There's one sigma bond and the other bonds are pi bonds. One bond is sigma bond and the other bonds are pi bonds. Therefore, between CB and CC, there's one sigma bond and two pi bonds. Therefore, statement C is not correct. Statement D, between CB and CC, there is one sigma bond and two pi bonds. The last statement is correct. Now we will check the answer. These are the instructions to get the answer for this question. If A and B are correct, the answer is 1. If B and C correct, the answer is 2. If C and D correct, the answer is 3. If A and D correct, the answer is 4. If any other number of combination of responses is correct, the answer is 5. According to the question, statement A, B and D are correct. Therefore, the answer is number 5.